I am Anil Kumar. Welcome to my series on trigonometry. We'll consider questions based on double angle in this particular video. You can treat this as a test review. The question here is, solve the following equation for x between 0 to 360 degrees, both included. Question number 1 is cos 2x plus cos x plus 1 equals to 0. Question number 2, 4 tan x tan 2x equals to 1. And then we have an identity, which is our question number 3. Sine 2x plus cos 2x plus 1 over sine 2x minus cos 2x plus 1 equals to cotangent x. So formulas which you might need to solve these questions, let me provide you with those formulas also. We are looking into cos 2x. So cos 2x can be written as cos square x minus sine square x. You could also write this as 2 cos square x minus 1 or as 1 minus 2 sine square x. Now the other one which you might need is tan 2x. So tan 2x will be what? Is 2 tan x over 1 minus tan square x, correct? So I think these are the formulas which may be required. With that, you can actually pause the video, answer these questions, and then look into my suggestions. Let's begin with the very first one, which is to solve cos of 2x plus cos x plus 1 equals to 0. So the idea is to write this in a quadratic form with cos x, correct? Cos 2x, we could write this as 2 cos square x minus 1. That will give us equation in cosine, right? Quadratic form. So we get this as 2 times cos square x minus 1 plus cos x plus 1 equals to 0. Now minus 1 plus 1 is 0. So we get 2 cos square x plus cos x equals to 0. You can take cos x as common. So that is 2 cos x plus 1 equals to 0. Now from here you get solutions for cos x equals to 0 and 2 cos x plus 1 equals to 0, correct? So let's figure out what are the solutions. So we'll try to solve 2, which is cos x equals to 0. Cos x equals to 0 will give you x equals to, within this interval, we have to find all the solutions between 0 to 360 degrees. So it's a good idea to kind of sketch the graph of cosine x to see where do we get zeros for cos x. So clearly we have these zeros which are at 90 and 270 degrees. So we can write this as x equals to 90 degrees and 270 degrees, correct? So we get two solutions from the first one. And now the other one is 2 cos x equals to 2 cos x plus 1 equals to 0. That means cos x equals to minus half. Now, cos x is minus half means we are interested in finding solution which will lie in quadrant 2 and 3. Use the cos rule, correct? So cosine is negative in these two quadrants. We can always find what is the related acute angle. So let's find alpha, the related acute angle. Now for minus half, you can actually use the right triangle also, for 60 degrees. It is half. So we know the acute angle alpha is equal to 60 degrees. So what are the solutions? The solutions are 180 minus 60 and 180 plus 60, correct? So we can say x is equal to 180 minus 60, which is 120 degrees, right? And also x is equal to 180 plus 60 degrees, which is 240 degrees. So that gives you a problem solution, as we have now four solutions. One is 90 degrees, then we have 120 degrees, 240 degrees, and 270 degrees. So these are the four solutions for the given equation in the domain 0 to 360. Perfect. Now let's take the next example, which is based on tan. So the question here now is 4 tan x times tan 2x equals to 1. So 4 tan x, 2x can be written as 2 tan x over 1 minus tan square equals to 1. We can cross multiply. 4 times 2 is 8. So we get 8 tan square x equals to 1 minus tan square x. Bringing it to the left side, we get 8 tan square x plus tan square x equals to 1, and that is 9 tan square x equals to 1. Now that could be solved. We can find what tan x is. So we can say tan x is equal to 1 over 9. We'll do square root. And whenever you do square root, you have to take plus and minus. So we get plus minus 1 over 3 as the value of tan x. Now it could be both negative and positive. That means within our domain, we get four solutions, right? Let's find the acute angle, alpha in this case also. So what is the acute angle? Well, acute angle or the reference angle will be tan inverse of 1 over 3. Let's use the calculator to find this answer in degrees. Shift tan inverse of 1 divided by 3 gives us a value equals to 18.4. So that becomes one of the solutions. Well, the other solutions are what? So we can write x equals to 18.4 degrees. We can say 180 minus 18.4. We can say 180 plus 18.4. And we can also say 360 minus 18.4 degrees. So these are all the solutions. So let's write down all of them. So it is 180 minus 18.4, and that is 161.6 degrees. And then we have 180 plus 18.4, 198.4. And we have 360 minus 18.4, 341.6. So those are the solutions for the given question. Perfect. So that is how you can find all possible solutions. Now let's take the next question, which is to prove an identity. So the question given to us now is sine 2x plus cos 2x plus 1 over sine 2x minus cos 2x plus 1, and that is equal to cotangent x. So we can always begin with the left hand side and prove the identity. Now what kind of formulas can we use? Well, we have cos 2x plus 1. The formula is cos 2x is equals to 2 cos square x minus 1. It can also be written as 1 minus 2 sine square x. Now which one should you use? That's a big question, right? See, normally what we notice here is cos 2x plus 1. So when you have cos 2x plus 1, it's a good idea to use this particular formula. Since we can bring this 1 to the other side and we get only 2 cos square x, right? So that is the strategy. So we can write left hand side as sine 2x plus, instead of cos 2x, I'll write 2 cos square x minus 1. We already have plus 1 there. It will cancel. Now in the denominator, we have sine 2x minus. Now cos 2x plus 1. So we'll use the other formula, which is basically 1 minus 2 sine square x, right? So we have 1 minus 2 sine square x, and we have plus 1. Now, this could be written as sine 2x can be written as 2 sine x cos x, and we have plus 2 cos square x. Correct? So we know sine 2x is basically 2 sine x cos x. Denominator will be 2 sine x cos x. See, minus 1 and plus 1 cancels, and this becomes plus 2 cos sine square x. So now we can take common 2 cos x in the numerator. So we get sine x plus cos x. In the denominator, we can take 2 sine x as common, and we get cos x plus sine x. Now cos x plus sine x and sine x plus cos x, one and the same thing. So it cancels. Perfect. And what you get here is 2 and 2 also cancels. We get cotangent x, which is right hand side. So that is how we have shown that the left hand side is equals to right hand side, and therefore we have proven the identity. Perfect. So that is how we should be solving such questions. So I hope these steps are absolutely clear. We were able to solve the questions with these set of formulas. We also used sine 2x as 2 sine x cos x. And we also saw how we could use these formulas effectively to get the solution in minimum steps, and that is kind of important to understand. I hope the concepts are absolutely clear. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.